Hi and welcome to freenetworkstudy.com. Today we'll be configuring RIP with static neighbors. RIP version 2 uses the multicast group 224.0.0.9 to exchange RIP information. In that particular lab, we're not allowed to use multicast. So looking at the topology, we see that router 2, 3 and 4 are connected via a frame relay network, which is a non-broadcast multi-access network. And that's a typical case where configuring static neighbors would be useful. So let's get started. On router 2, let's check that we don't have RIP enabled. Show IP protocols. Alright, let's configure it. Configure terminal router RIP. We're told to use version 2 and variable length subnet masks. So no auto summary. Now let's configure the networks. Network 10 0.0.0, network 2.0.0.0, and 22.0.0.0. On router 3, show IP protocols, nothing. Router RIP, router RIP, version 2, no auto summary. Network 10.0.0.0, network 3.0.0.0, that's for the loopbacks. Network 33.0.0.0. Now let's configure router 4. Show IP protocols. Router RIP, version 2, no auto. The networks 10.0.0.0, network 4.0.0.0, and network 44. Let's have a look at the IP routes. Show IP route RIP. Nothing. Show IP protocols. So we see that RIP is running and it's enabled on all three interfaces, but it's still not receiving any updates. Let's have a look at this serial interface. Serial show interface. Serial 1/0. It's up. It's looking good. Show run interface serial 1/0. Okay, looking at the frame relay maps, we see that we do not have the broadcast keyword. That means that the multicast packets sent by RIP are not being sent to the other routers. That would explain why we are not exchanging RIP updates. To solve this issue, we'll have to configure RIP neighbors statically. So let's start here on router 4. conft router RIP, and we'll be using the neighbor command. And the neighbors are router 2 10.1.1.2 and router 3 on 10.1.1.3. Let's do the same thing on router 3. Neighbor router 2 10.1.1.2 and router 4 10.1.1.4. Now back to router 2, neighbor 10.1.1.4 for router 4 and .3 for router 3. Now let's check if router 3 has some routes. Show IP route RIP. That looks better. Router 3 can see router 2 and router 4. Do we have IP connectivity? Ping 2.2.2.2 and 4.4.4.4. That's not working. Let's see here. Oh, router 2 has the IP address 10.1.1.1, and I'm pretty sure I configured 10.1.1.2 on router 4. Let's jump back to router 4. That's right. So I configured the wrong neighbor here. I'll do a no neighbor 10.1.1.2 and neighbor 10.1.1.1. Now let's jump back to router 3. That's working. Let's have a quick look at the IP routes here. Show IP route RIP. And here's something interesting. The route to router 4 has a metric of 1. That's because we configured router 4 with a neighbor command as well. We could have established end-to-end IP connectivity with only one neighbor command on router 4 and router 3. And in that case, router 3 and router 4 would still see each other, but this time with a metric of 2, since router 2 would be advertising each other's routes. Let's just verify that that would definitely be the case. On router 2, show run interface serial 1/0. So we see that split horizon is enabled. Then the neighbor commands on router 3 and router 4 were definitely necessary. But it's good practice to disable split horizon on the hub in a hub and spoke network. So just to practice how this is done, let's just do it here, even though it's not necessary. Conft interface serial 1/0 and simply no IP split horizon. Do show run interface serial 1/0, and that's gone. That's it. Thank you for watching.